Last sample problem. Silver chromate is insoluble. It forms a brick red precipitate. Calculate the mass of silver chromate that forms when 50.0 milliliters of 0.100 moles per liter silver nitrate reacts with 25.0 milliliters of 0.150 moles per liter of sodium chromate. So the first step, what we want to do is we want to come up with our equation. So here is our equation. Okay, so it's really important that you're really careful when putting together your formulas and writing out your equations. Now, what we want to do is we have information on our two reactants. We've got 50.0 milliliters. Okay, so we've got the volume here. We've got the concentration of silver nitrate. Using that, we can actually find the number of moles. We've got the volume here, the concentration of the sodium chromate, which is this, right? So we can use that again to find the number of moles. What we're trying to do is ultimately find that one, right? That's what we're trying to find. We're trying to find the mass of the silver chromate. So, because we've got volume and concentration, what we can do is actually use that to find the number of moles. So let's look at the number of moles of the silver nitrate. So the silver nitrate, remember, milliliters for volume, make sure you convert them to liters. Okay, that's the first step. Now, so we've got 0.00 liters, right? That's the volume. So we've converted this to this, 0.0500 liters. We're going to multiply that by the concentration, which is 0.100 moles per liter. Liters cancel out, and I'm left with 0.00500 moles. I'm going to do the same thing now for my other reactant, which is the sodium chromate. So here is my sodium chromate. I'm going to take the volume, which has been converted to 0.0250 liters. I'm going to multiply it by the concentration, which is 0.150 moles per liter. Liters cancel out, and I'm left with moles. So my answer comes out to 0.00375 moles. So that's what we have now for each one. So what we want to do is we want to figure out which one of these is the limiting reactant, or which one of these is the limiting reagent. So what I'm going to do is I'm going to erase some of this information. Okay, so we're just going to put this work aside. So let me just get rid of this, and we're going to label it on the actual equation itself, so we can actually see what these parts are actually equal to. So what did we create for the silver nitrate? So for the silver nitrate, we got 0.00500 moles. The sodium chromate, we got 0.00375 moles. So now what we want to do is we want to figure out which one is the limiting reactant. So just like we did with our stoichiometric methods, all right? Our unknown, that's the number of moles. So we want to try to find the number of moles of our unknown, and our unknown is going to be this, the silver chromate. So we've got Ag2CrO4. All right, sorry about the mess. We've got moles, we've got molecules. Now, how many molecules do we have of this unknown that we're trying to find? Well, according to our balanced equation, we have 1. So now, let's look at our first one. We have silver nitrate, and we've calculated, and just to fit it in here, 0.00, I'm going to just include the 5 and without the 2 zeros just to fit it into my, my box here. So we've got how many silver nitrates? Well, we've got 2 of them. And lastly, the other one that we've got is the sodium chromate. And how many moles have we created? 0.00375 moles. How many molecules do we have? Well, we have 1 of them. So what we want to do is we want to figure out the number of moles that silver nitrate is going to get of the sodium chromate. The silver chromate. And then how many moles is the sodium chromate going to make of the silver chromate? So what we're going to do, right, just as we said, separating both sides, and we've got X over 0.005 moles equals 1 over 2. So in blue we have is the silver nitrate information. In black we have the silver chromate that we're trying to find. So what we want to do is we want to isolate for X, bring the 0.05 over, and we get 0.005, right, times 1 over 2, which the answer will give me 0.00250 moles. Then we're going to do the same thing, right? X is our unknown, but this time, right, we're going to be comparing that ratio with the with the sodium chromate. So we've got 0.00375 moles equals 1 over 1. And anytime you have a 1-to-1 ratio, really there isn't any work to be done. 0.00375 moles. So between this and this, which has the lower number of moles that we're going to create, that will be our limiting reagent or limiting reactant. So this is our lower number of moles that we can calculate, and that was achieved from the silver nitrate. So what we're going to do is we're going to take that information and we're going to use that because we're going to create 0.0250 moles of this. So using that, right, using that information, we are actually going to be able to use that with the molar mass to help us find our actual answer. So what we're going to do, we've got our number of moles, and that's 0.00250 moles. We're going to multiply it by the molar mass, right, of this, the molar mass of that, sorry for those who can't see it, which is 331.7 grams per mole. Moles cancel out, I'm left with just grams, and when I multiply those two together, my answer comes out to 0.829 grams of the silver chromate.